Hello everyone! In the last video I introduced you to the concept of functions. In this video we will have a look at a specific type of function, namely linear functions. We will have a look at the concepts of gradient and y-intercept, and we will have a look at how you can calculate the point of intersection between two such functions. We have seen both of these topics before with linear formulas, so I'm going to try to keep it short and mostly point out how similar the functions and the formulas are. So let's start with the gradient and y-intercept, and with that I'm actually going to start with a linear graph. As you can see, it already has the f in there for the name of the function. Now we have seen the standard form of a linear formula before. That was y equals ax plus b. For the linear function we can basically do the same thing, except this time we call it f, and we specify that x is our independent variable. So we get fx equals ax plus b. Now let's have a look at that gradient and y-intercept, starting with the y-intercept. The y-intercept is the point where the graph crosses the y-axis. That's right over here. And in the function, it is the number b, the variable b. The number that is added or subtracted at the end. And this makes it the number that is still left even if x is 0. If x is 0, the whole ax part disappears, but the b still remains, the y-intercept remains. Alright, then the gradient. The gradient tells us the steepness of the graph. How much our graph goes up or down for each step to the right. That means that it also tells us whether the graph is going to rise or fall. If the gradient is positive, the graph is going to rise. We're constantly adding something. Whereas if the gradient is negative, we are going to have a falling graph. We're constantly subtracting something. In our function, the gradient is the number a. It's the number that is added however many times we have x. So in this specific case, we have a y-intercept of 2 and a gradient of 4 because it goes up 4 steps in that one step to the right. So we have the function fx equals 4x plus 2. Enough about gradient and y-intercept. Let's have a look at the point of intersection. Now, to even have a point of intersection, we're going to need two functions. Let's take these two. And of course, we can start by plotting them, but in this case, that's not very useful. We can't really read off where they intersect. Now, if they were formulas, y equals something, we would set them equal. And that is what we're still going to do. We're going to set f equal to g. And that's going to look like this. 4x plus 2 equals minus 3x plus 5, just filling in those functions. And this gives us a linear equation that we can solve. I'm not going to get into how it's solved. If you need a reminder on that, please have a look at my video on solving linear equations. But in this case, it's going to give us the answer x equals 3/7. Okay, and well, that seems about right. X is 3/7 is pretty much where it's at. But for the point of intersection, we also want to know the y. We also want to know the second coordinate. And for that, we just fill it into one of the functions. We calculate f of 3/7. So we fill that in, 4 times 3/7 plus 2, and we get 3/5/7. Now what you can do is you can still fill it into g as well, and you will find that you get the same answer. And from that point, you can draw your conclusion and say that the point of intersection is 3/7, 3/5/7. And again, the 3/5/7 also seems to make sense. It is just a little below 4. So let's repeat quickly what kind of steps we did. We started by setting them equal. That's where you always start when finding the point of intersection. Then you solve the equation you get. You fill it into one of the functions. It's up to you which one you want to fill in. If If you have the time, you can check it with the other function, and finally you draw your conclusion. That's all I have to say about linear functions. I hope this helped remind you about what the gradient is and how you can calculate the points of intersection.